acceleration is a change in velocity over time. So change in speed over time. Remember, speed and velocity are sometimes used interchangeably. However, speed does not indicate direction. It just shows how many, the distance over time, whereas velocity is distance over time with a direction. But if we look at acceleration, it is the change in velocity over time. So how would we graph acceleration? Remember this delta, that's the Greek symbol that means change in. So that's going to be velocity final minus the velocity initial, right? So F and I, final, initial. Sometimes you'll see an O for original velocity. That's the velocity you start with, over T. Okay, so how would we put this in a graph then? So we're looking at a rate of increase or decrease in the speed. So really, think of rise over run, graphing. So remember, x-axis should be the independent variable. So time is the independent variable here. The dependent variable goes on the y-axis, so speed in this case. Okay, so I'm just going to say, we're looking at a car, and I'm going to see its acceleration. Okay, the speed, I'm going to say this is miles per hour. Okay, normally in science we use meters, but since we're looking at cars, they oftentimes use miles per hour. How fast they go. Okay, so now I've got from 0 to 100 miles per hour, and I have time. And we're looking at a car driving over time, over 10 seconds, and its speed. So we're looking at speed versus time. Remember, that's going to be acceleration. So, from 0 to 1 second, the first second, notice the speed is increasing, right? Started off 0 miles per hour. After 1 second, we're 20 miles per hour. So there's acceleration happening here. And we can figure out how much acceleration by using the formula. A equals change in V over time. If I want to know what's the acceleration of the car during this time, it would be A equals the change in speed. So the change in speed, remember, is going to be VF minus VI over T. Right? So the final velocity, I'm looking at the first second now. So just this part, just this one, I just want to see what the acceleration of the car is right here. So the time is 1 second. So T is 1. The change in velocity is what we have to figure out. So the final velocity in that second is here, right? It's 1 second, and it's 20. So 20 is the VF. The initial velocity is 0. It's not moving. So 20 minus 0, which is 20, divide by 1, 20. So the acceleration rate is 20 miles per hour. During that first second, that car is accelerating at a rate of 20 miles per hour per second squared. So if it kept going at that same acceleration, the next second, it'd be twice that. So every second it's increasing by 20 miles per hour. But it doesn't do that. So we can see from time 1 to time 3. So between 1 and 3 seconds here, the speed stays the same. So the speed is not increasing. So at this time there's no acceleration. Acceleration is going to be 0. Because remember, acceleration is the change. There's no change, it's 0. Acceleration is change in velocity. If there's no change, it's 0. Okay, so acceleration here is going to be 0. Now, we want to know what the acceleration here is. Actually, let's make, yeah. So we're going to say we go from 3, I'm going to make this 5. 3 to 5. So we're going from second 3 to second 5. So the difference is 2 seconds, right? So we're looking at the time is 2. So t is equal to 2 seconds, right? Because we're going from 3 to 5. It's 2 seconds. So we want to figure out what the acceleration of the car is in this part. We're going to have same formula, Vf minus Vi over t. T is 2 this time. Okay, the final velocity is 60 miles per hour. 60. The initial velocity is 20 miles per hour. So 20 is the initial velocity. So 60 minus 20 is 40, divided by 2, 20 miles per hour. And that makes sense now, because look at really the slope is like the same. These two, the slope's about the same, look the same. So the acceleration rate is the same, 20 miles per hour per second squared. Now, over here, we can see between time the 5th second and let's say the 8th second, 5 to 8 seconds. Time is going to be 3 seconds, right? Because there's 3 seconds between these. So 3, t's 3. But look, the speed stays the same. It's at 60 miles per hour. So the acceleration is 0. It's not changing speed. Okay, then we go to the next one here, this part here. So we're going to go from, I'm going to say this is 1 second. We're going from 8 to 9. 1 second is the time. And we're going to use the same formula, velocity final minus velocity initial over t. T is 1 in this case. Final velocity is, we're going to say it's 90, and we'll say the original velocity is 60. So 90 minus 60. Okay, so then 90 minus 60, 30, divided by 1 is 30. So here, acceleration is faster. In other words, accelerating faster. It's speeding up more right here. Slope looks a little different. So 30 miles per hour per second is the amount that car is speeding up. So for every second, it's increasing by 30 miles per hour. Here, we're at 90. There's no change in speed, so acceleration is 0. So to look at a graph like this, when you're trying to study acceleration, you're looking at the change in velocity over time. Is the speed changing? Is it speeding up? Is it slowing down? Okay, so for the first, so we're going to go right. When you read graphs, you're always going to read from the 0, just like left to right. How you read in a book. You read left to right. That's how you read graphs. So we're always going to start here. So from 0 to 6 seconds, the acceleration is 0. It's going 90 miles per hour, the car, for the first 6 seconds. Now, from 6 to 10 seconds, we have a change in speed. So we're going to figure out what is its acceleration of the car here. So remember, acceleration, V final minus V initial over T. So the final velocity, let's say it stops right at 10. initial velocity is 90, and the time is 1, 2, 3, 4 seconds. Okay, now acceleration can't be a negative number. So if we're looking at negative, it's just deceleration. So it means it's slowing down at that rate. So we're just going to take, if we were to figure this out, 10 minus 90 is the same as 10 plus negative 90. And you take the sign of the larger number and subtract. So negative 80 divided by 4, which is equal to negative 20. However, like I said, we're not using negative numbers, so it would be 20 miles per hour per second squared deceleration.